Hi, today we talk about unbranded PLC analog module calibration. Actually, all the analog module don't need calibration, but all the analog module is calibration at the factory. So you don't need recalibration. But if you want to do some specific application, maybe you should do recalibration. First, we talk this compact logics analog module. You don't need more calibration. It's always the auto calibration performed when a channel is initially enabled or the channel is configuration is different than the previous channel. The auto calibration cycle is run as part of the reconfiguration process. So he do configuration, he do initial this module, he just automatically calibration. So we don't need the module field calibration. But in the control logics, the analog input module, if you want to go to the very high accuracy, it's the signal with very high accuracy result, you should do calibration. But if you want to do control logic calibration, you first put the figure out if you first add to the system. Okay, look like this. Then go to the property, go to calibration, then do start calibration. First, you show the connection is calibrated to the channel, every channel. Okay, then follow this step by step to calibration. If you want to control logics and log input output calibration, you should follow the control logics module menu. The menu tells you detail what's going on. Okay. Yeah, he told calibration the control logic and log AO module. Okay. If you want to do something, you should follow this menu. Do something. Okay. Today we just talk about is the LSC 500. It's analog module. It's the 1746 NI4. How to use the program to calibration. Is S500 module is a controller, is out of service, but it's very popular still in the site. So sometimes I think we should do calibration. Sometimes if you have very high accuracy application, we should do calibration. But this calibration just option. It's not necessary to do some calibration, but unbrandedly recommended to do calibration. If you want to do 1746 NI4 calibration, you should know the specification of this module. We should open this the menu. We can find the specification. Then you should follow this menu step by step, do this calibration. Then you should do program for this calibration. Just not the same thing that control logic is very complicated calibration. Okay. First, we go to this menu. We got an information from the menu 1746 NI4. He used the 4 MA to 20 MA input use. Its resolution is 16 bits. Converter resolution is 16 bits. Its converter input coding is minus 20 MA to 20 MA. So its digits number is minus 16384 to 16384. Its offset error is positive, negative 7 LSB. What's mean LSB? LSB is analog ADC and DAC least significant bits. ADC is called analog digital converter. It's in the analog input module. The DAC is called digital analog converter. It's located in the analog output module. If ADC just use this way, for example, is outside the signal 4 to 20 mm, go to the analog input module. Is analog input module use ADC convert the digit bits. If your digit bits resolution is 16 bits, for here is the 8 bits. So 80 bits is 0 to 256 number. Okay, 256. So 1 bit is just 1. Okay, this LSB. This called 1 LSB. For example, if 2 volts applied to the input module is 8 bits ADC, is 1 LSB equal 2.5 divided 256 equal 9.7656 millivolts. This is the signal. 9.6 is the signal. Okay. If you are 2.5 volts, if you use 16 bits resolution, is 1 LSB equal 38.50 UV. Okay. Is the overall error for the NI4 1646 NI4 module, which is guaranteed to be not more than positive negative 0.365%. What means 0.3%? 0.365% is the at 20 MA equal to 0.6 LSB for error. In here is offset error. Its range is minus positive 7 LSB. But in here is more than minus positive 7 LSB is overall error. So is the 60 LSB is called range is 16324 to 16444. Any value in this return by an analog input channel to the 20 MA. That means error is cleared. Error. So maybe the 18 MA he just sent to the analog is become 20 MA. So expected nominal value at 20 MA is 16384. Okay. So if you do calibration in the analog input module, if you perform this, use the software calibration, the overall error is reduced 3 LSB. The code range is 16381 to 16387. It's very narrow. Okay, that's very perfect. This is how to calibration. Yeah, This is all the same thing before we calibration in the traditional. Yeah, we should figure out the offset and the slope. We figure out offset the slope. The 1746 NI4 card is no value, so from 3267 to 16396. But our application use 4MA is 20MA. Is 20MA 16384 is 4MA 3277. So we just use the IS Logic 500 software to program how to use this one, how to figure out its offset, its slope. Then the result, we figure out the offset, the slope, send it to analog input. That's called calibration. Okay. If you do this calibration, we show the connection is calibrated to the analog input module. The procedure is LSC 500 1746 NI4 is analog module with the calibration. First, you put the normal operation temperature. If you need the temperature is environment is stable, okay, not fluctuation, not vibration, okay. Then you should decide the scale high or low value. We decide is high value is 20 MA, low value is 4 MA. Is high value 20 MA, is scale is 16384. Is low value 4 MA is 3277. Okay. Then we use analog input calibrate source is calibrate flock calibrator to connection to this channel. Then send is 4 MA to the position. They capture the low value by the calibration on input. Is the input capture this 4 MA position. Then he just configuration is analog input. Okay. After that, use analog input calibration source, put the 20 MA high value. MA is capture high value is 16384. Okay, then calculation of the stuff, then figure out the slope and the offset. This energy the calibrated input that causes the LSC to calculate the slope and offset value used to perform the error correction to the analog input. After that, do this calibration, the analog channel is no calibration to 0 positive or negative 3 LSB at the calibration temperature. So use the offset error drift, gaining error drift to calculate the moment additional error that can be introduced into your system due to temperature variation. Okay. This is my how to connection. This, for example, this is channel 0. Your connection is a flock, is a process calibrate. Then send the source is 4 MA, go to here, go to the input module, then input module calculator, then is the calculator. Then after that, send the 20 mA go to the channel 0. Then PLC program calculator is 4 mA is the number and 20 mA number. After that, he decide offset and stop. That's it. The manual, he recommend the calibration is every 6 months, but sometimes he thinks it should be performed every 3 to 4 months. Just for this option, if you're very, very high accuracy application, use this calibration. Okay. Today we just talk about how to do calibration. Is 1746 NI4 is analog input module. Next time we talk about how to use ICE Logic's 500 program to do this job. Okay, thank you very much.